tests. We are back on our regular homework schedule, so there's homework due on tomorrow, I guess. All about regular expressions. Maybe I'll refresh our memory a little bit about regular expressions. That's what we started talking about last week. Regular expressions are things like, A star BA plus B star plus A star. What does that mean? We use the word matches certain strings, and I hope everybody remembers. The plus means or, and the star means iterations. So this thing matches anything that looks like a bunch of A's followed by BA, or anything that looks like B, just a bunch of B's, or just a bunch of A's. So this, if I were to write this using sets, this matches something like A to the n BA union B to the n union A to the n. Sometimes regular expressions is just like a better way than writing it as sets, but this is how I would write the same bunch of strings in ordinary set theory, right? Regular expressions, it's a nice way to write things if you don't want to write ordinary set language. So last time we did a bunch of examples. Maybe I have a lot of examples written on my paper, and I can't remember exactly which ones we did last time. But for example, we could do something like, how about all strings containing BA as a substring. That means it can have anything, but somewhere inside the string has to be a BA. I would write that as something like A plus B star, BA, A plus B star. This A plus B star is something that you see a lot in regular expressions examples. It basically, like that much of it just means sort of anything. The star means you can go through these parentheses over and over again, and you don't have to sort of choose, inside the parentheses it says A or B, but when you're iterating through with the star, it doesn't mean you make the same choice every time. And so it just means here you can take any combination of A's and B's. Here you can take any combination of A's and B's, and there just has to be a BA in the middle somewhere. This, I think, is the most sensible way to write that language as a regular expression. How about something like A to the n such that n is even? Can anybody give me a regular expression for that? I think there's a similar one like this on the homework. A to the n, yeah, where n is even. AA in parentheses star, yeah, great. AA star. That means you take two A's at a time, and you can repeat that as many times as you want. That's going to give you all possible A repetitions of A where the number of repeats is even. Yeah, great. How about something like, well, I was going to say, like, how about A to the n where n is a multiple of 3? That would just be the same business, but with 3 A's, right? How would you make it so that the n, A to the n, such that n is odd? Here's a hint. It's not that. This doesn't make the length odd. It means you're taking 3 at a time and repeating them. So you're going to get 3 or 6 or 9 or 0, of course. If you wanted to make the length odd, I would say the proper way to think about that is do this where the length is even, but then insert one extra one. But don't put it inside the parentheses out here. Then it means you get one A sort of for free, and then you get some even number of A's right next to it. And that's how you would make it odd, if you wanted to make it odd, right? How about any x in AB star such that the length of x is even? So this means I want an even amount, but they're not all A's. They could be anything. Any thoughts about that one? Yeah? Nope? Anyone got an idea? I would think of this as kind of like this. Modify this so that it doesn't have to be A's every time. It could also be, A's or B's, I suppose. There should be two of them. Any ideas? Yeah?
A plus B, A plus B.
Yes. And you mean like this?
Yeah.
And another little something.
Star.
With a star, yeah, on the outside. I think that's what he meant. Yes, you better put all those parentheses in there. Actually, all of those parentheses are necessary. A plus B, the whole thing star. Great. This looks like 2 letters at a time, right? Where the first and the second are either A or B, and then you take repetitions of that. Yeah, great. This can be a little tricky, I suppose, sometimes. One thing that I meant to mention, even like up here, I will just say, note, this is different. I'm not sure I made a big deal out of this before, and I think probably everybody has gathered this along the way, but this is different from AA star without the parentheses, right? So if I see AA star with no parentheses, I interpret this as meaning the star only applies to the A, not to the other stuff. So this is kind of, I suppose, a little bit of order of operations. The star generally applies only to the single letter that precedes it, unless there's parentheses. This is why we have parentheses for things like this or this. All right. What would can anyone say in words, what does this set represent? A star? This one is they're all A's and it's an even amount of them. This one is, I mean, they're all A's, but what can you say about how many there are? Yeah?
At least one.
Yeah, this just means at least one A. So that first one is straight up like literally there's just an A, and then followed by some number, possibly 0 more A's. Yeah, great. Okay, I had just one more here. How about X and AB star such that the number of A's is even, but I don't know. I don't care about the number of B's. Only the number of A's is even. Could be any number of B's. Anyone got a thought about this one? This one's a little trickier, I suppose. I would say, as a hint maybe, I would say it's kind of like this. This has only A's, no other stuff but an even amount of them. I want to do something to maybe modify this a little bit so that it still has the even number of A's, but there could also be some B's in there. Any ideas about that? Yeah.
Could be in parentheses AA star and out of parentheses plus B and then B parentheses star.
Okay, I like this. This is not quite right, but I like that. So that means, like, you go through the outer star, and each time you either pick AA or you pick a B, and then you keep doing that over and over again. So I think this definitely will have an even number of A's, but actually there are some strings with the even number of A's that you can't make out of that, I think. Anybody agree? Something like this one, you cannot make ABA from that, because this requires that all your A's be like next to each other in a block AA. Any ideas to rectify that? I think actually the idea that I have in mind doesn't really look a lot like that. I mean, kind of. But any other idea? Yeah?
Is it B star, and then in parentheses, AB star, and then star those parentheses?
Like this?
And then,
Or with the star outside there? Or like that?
well, then you'd add another AB star
And then
in the parentheses that you made, right?
like this?
And then star the parentheses outside, yeah.
Okay, yeah. Actually, this is close to what I had in mind. Can you explain what your insane thought process is to come up with this?
So it can have any number of B's in front of it,
Mm-hmm.
and then there's 2 A's inside of parentheses, but there can be any number of b's inside the parentheses, and as long as you repeat that as many times as you want, there'll always be an even number of a's.
Yeah, I like this. We have inside, so like these parentheses and the star are just like these parentheses and the star up here. But what he's done is just said, like, you can insert extra b's in there wherever you want. So I have 2 a's being repeated, and then there can be more b's in there however you like. So actually I had, and this is totally fine, what he said exactly. I said, this is the idea that I had written down on my paper, which is really the same, only I put this b star inside. They are equivalent regular expressions. To me, this one makes a little bit more sense just because you can see very clearly. All I'm talking about is repetitions of 2 a's with just some extra b's in there wherever you want. Excellent. Actually, there is one technicality which makes this not quite right. Anybody see? And actually, his version is correct in a way that mine isn't. There is a slight difference here, and that is that in his version, you can do this parentheses 0 times and just end up with b's all by themselves. That's impossible here. There's no way to get, for instance, b. You can't make just b out of this. All right, because in order to go through these parentheses at all, you're going to pick up 2 a's. But I said the number of a's is even. That should include when the number of a's is 0, right? So to make mine correct, you have to do just a little technicality, or b star, meaning any number of b's all by themselves. Although this extra bit is not necessary if you're doing it this way here. All right, I like that. Excellent. So these can be a little tricky, I suppose, from time to time. Any thoughts about any of these? This is just to get us back up to speed about regular expressions. Great. So the sort of big question that I want to talk about, which is not all that hard to answer, but it's something we're going to spend the rest of today on and maybe a little bit next time, is the usual question that we ask about these sorts of things. Which languages can be generated by regular expressions? All right. All the examples we've just done, of course, those ones, you can make regular expressions for those examples. But it's probably, it should seem reasonable to you that probably there are languages that are so weird that you can't make them using regular expressions. If, like, all we have at our disposal is the star and the plus, basically. And I feel like that can probably express a lot of different types of things, but probably not everything can be generated by regular expression. I want to try and answer this question kind of in 2 parts. First part is we can actually convert any regular expression to NFA. And there's a fairly easy way to do this. We can convert any regular expression to NFA. What does that mean about regular expression languages as opposed to the regular languages? I think it means that every regular expression language is a regular language. That's because, remember, regular language means it is the language of some NFA. And if it's really possible, what I'm saying is that you can convert a regular expression into a NFA. That means automatically all of those languages must be regular because you can convert them into a NFA. Anyway, let's try and talk about this. So it's actually a fairly straightforward procedure once you see how to do it. What we're going to talk about is let's convert to NFA according to the operations. So really, if it comes to converting a regular expression to an NFA, it will be enough if we can just describe something like, how do I express the plus operation in terms of NFAs? How do I express the star in terms of NFAs? And then how do we express sort of putting one thing after another? So like, for instance, if R1, well, let me say first, we're going to describe how to combine regular expression parts together into NFAs. So for example, if I have something like the language of ABA plus B, well, I can think of a regular expression for ABA. ABA, I mean, as an NFA, would just be this, right? That's an NFA for just ABA. It accepts ABA. And what's an NFA for just B? That would be something like this, right? So individually, those two strings are easy to make NFAs for. The real question is, how do I combine them with a plus? And you just have to think, plus means or you could think of a plus as representing a union of sets. Does anybody recall, this was on the homework maybe last week, there is a standard way to make NFAs for unions. Anybody remember anything like this? There were some problems in the homework where you had to make an NFA for a union. And it involved using epsilons in a cute way. Anybody remember this? Yeah? Do you remember how to do it? How did you?
The starting state with epsilons is the NFAs for each.
Yeah, right. You make a starting state which just has epsilon arrows to sort of like two parallel roads or something like that. So to make the plus, we do like this. I have a starting state, two epsilons, and then the top one goes through this one, right? I'm combining those two from before, like that, right? So if you see the plus operation, you just, and these are just, basic principles that we will remember. If you see the plus operation, that corresponds to one of these starting state with two parallel tracks in it, all right? Generally speaking, can I say it this way? For the sake of making, that was a very simple example that I just did, but for the sake of a much more complicated regular expression, we want our NFAs, I'll explain why in a moment, to have just one accepting state. I'll say why in a moment. But if you have something like the language of R1 plus R2, so if R1 and R2 are two different regular expressions and I want to combine them with a plus, the way to do that is what I just said. You go like this, and then maybe I'll sort of put R1 in a box here, R2 in a box here, right? And because of this technicality that I said just off the top of the screen right now, I said I want our NFAs to have a single accepting state. If you want to make that happen, you can just sort of tie them both together at the end into a single accepting state. All right? This is how you combine two regular expressions using the plus operation. R1 plus R2, you would do this to it. Why do I want a single accepting state? It's because I'm gonna be talking about various different constructions about how do we combine things with the plus, how do we deal with a star, how do I deal with one part of a regular expression listed right after another one, and in terms of chaining them all together, it's most convenient to do that when there's only one accepting state. All right. So anyway, this is the rule for R1 plus R2. I suppose you should memorize this, I guess, but it's we're going to do enough examples. I don't think you ever have to like sit down and memorize it. All right. What about the other operations? There's the star. The parentheses don't really count as an operation, but there's also the operation of just writing two things next to each other. R1 followed immediately by R2. All right. That is, if you have two regular expressions and you're just writing them next to each other. That's an operation. It means whatever your string is, it has to match, like the first part of it has to match R1, and the second part of it has to match R2. And how would we convert this into an NFA? It's actually just like this. This is sort of these two things in parallel, but instead of in parallel, you put them like one after the other, in series, as the engineers would say. So this one looks like I start going into R1, and then wherever the end of R1 is, I patch that directly into the beginning of R2, and then wherever R2 ends, that's my accepting state. All right. And here you can see maybe why it's important in these constructions that we always have a single final state that will allow you to actually patch these things through. If somehow this R1 had like 3 different accepting states, then it wouldn't be clear. What do I mean when I say you just put this one after this one? But if they all have one accepting state, then everything works out great. So this is our second kind of nuts and bolts construction. All right, when you see one thing after another, this is how you chain them together. And then we should talk about the star. So what about L of R star, where of course R could be a more complicated thing, not just a single letter. All right. Now this is only one thing, so really, I mean, it's going to look something like you go through R, and then what? I guess the end of R comes out. It sort of has to look like this. This would represent you are allowed to just go through R once. Anyone want to suggest, could we maybe add some more epsilons here to make this diagram so that you can go through R several times if you want to? Yeah?
R goes back to the beginning.
Yeah, how about another epsilon from here back to the beginning? All right? This will make it so that you can repeat, go through R as many times as you like. All right. There's one little, this is almost correct, there's one little technicality. Anybody see, when you do the star refers to 0 or more times through R. Can we see something is not quite right about this? Yeah, this does not allow for 0 times, right? Because the only way to make it to the accepting, in this one is just by going through R. So you need to make it so that you can, if you want to, skip over R. And the way that we do that is with an epsilon like this. All right? So this is the last of our sort of little schematics that you need to remember how to do. All right? I've heard this referred to as the burger. This is what I think last year one of the students I heard called this. This is the burger. If you want to make the star, you just do the burger. All right. And every sort of larger regular expression can always be broken down into these little bits and then kind of patched together. So let's, as a fancy example, can we try something like how about an NFA for A plus B A, right? So I'm going to break this down. Now I see a plus in there, although at the largest level, what I see is a concatenation. This thing followed by A, right? This is like a R1 followed by R2. And then the first of those things is one of these pluses, so I'm going to draw that as a 2 branching path. So I'm going to start with this 2 branching paths. The first one is just A, so it's like that. The second one is just B, and then we tie them back together into a single final state. So what I've drawn so far, that's the A plus B part. This is A plus B, right? And then I want that to be followed immediately by A. And so I can just do that. So this right here is sort of the A. All right? Now this you probably didn't need to learn all of these different techniques to do this. Like this is a very simple one anyway. A or B followed by just a A. But that's this is how I would make an NFA out of that. All right. Let's try a more complicated one. That was sort of uncommonly simple. How about A, AB star, A plus B. All right? So again, you look at this, I would say at the large scale, this is again a concatenation of 3 parts this time. I see just A, and then this thing, A plus B star, and then that thing, A plus B. So just A is really just A. This AB star is going to be like one of those burgers, and then this A plus B will be a branching path at the end. So it would look something like, and if you like, you could draw these pieces separately, maybe just for the sake of writing out a lot of details. I'll do that just once. This would be just A. If I want AB star, okay, that's A, B, epsilon, and then like this. This AB star would look like that, sort of the burger with AB on the inside. All right? And then we have A plus B at the end, and that is one of those 2 branching paths. That looks like A up there, B down here. Of course, there are much easier ways to write these NFAs. Like, for instance, that last one, you could really just write it as A comma B like that, right? That's a much simpler version of the same thing. But for the sake of drawing these and then patching them together, it is often more convenient or just easier to keep it straight in your mind if you use the bunch of epsilons. All right, anyway, my final answer then is just these 3 things, one after another. So for A, AB star, A plus B, it looks like I have my starting state goes A, and then this is AB star. So I'll go A, B, like that, and then burger, burger. Now I wrote this, see here I used fewer of the epsilons. If you want to sort of like abbreviate and omit some of the epsilons, that's fine, although don't leave out the important ones. Like these epsilons you definitely need because they are the ones which express the fact that you're doing a star. But these epsilons on the inside are really not necessary. And then finally, this one I will do like this. And of course, I make the final state at the very end accepting. Right, there you go. Any thoughts about that one? So really, no matter how complicated this regular expression looks, you can always break it down into a bunch of stars, pluses, and concatenations and patch them together however you need to. I got one for you to try. These are never really, I mean, there's no funny business really. You just have to work it out. You may find it helpful to write it like this one that I just did. I wrote sort of, I wrote out the little pieces first and then patched them all together. Or maybe if you wanna impress your friends, you can try and do it all at once. That's fine. Yeah, you should use the usual order of operations for math. So this is like low precedence. So the grouping really goes like they should be grouped like that. Yeah, just like they would be in algebra. All right, can we talk about these? It looks like people are doing fine. So I have drawn a squared plus b star. I have AA across the top and B across the bottom, and then these epsilons of to and fro are making the star. And now to make A squared plus B star BA, to follow this by BA, I would just at the end put BA. Like that. All right, so now so far I've done, actually this is everything in the red box, right? And now I want to make that stuff or epsilon. That means I plug this in as like 1/2 of a plus construction, which is the two parallel routes. So this, I suppose, is my final answer. This is the starting state. It goes 2 parallel tracks. One goes through the top one, which is all that stuff, A squared plus B star BA, and the bottom one just goes through epsilon. And then this shall tie together like that. So something like this is what I would say. There's an epsilon there on that arrow. As I was going around, I saw this is pretty much what people had, so I hope everybody feels good about that. All right. In this way, any regular expression can be converted into NFA. I think once you get a feel for it, this is not all that difficult to do. So maybe I will say, so let me just say, any regular expression can be expressed as a NFA. And what that means is, so the language of any R, regular expression R, is always this is what I said before, regular language. Remember, regular language just means it is the language of some NFA. So any regular expression, you can rewrite it as a NFA. So its language is a regular language. We should consider the other way around, though. Is it true that every regular language can be written as a regular expression? Another way of asking that is, if I start with an NFA, can I convert it back into a regular expression? Because if that were true, then really these things, they would be the same as the NFAs. In fact, that is also true. So let's talk briefly, and we'll say some more about this next time, I think. Converting NFA to regular expression. Can we go the other way around? And this is more complicated. So I'm going to draw a slightly complicated NFA here, and then see if we can write it as a regular expression. Of course, if your NFA already looks like a bunch of burgers or whatever, then you can convert it back to a regular expression, but it's probably not going to look like that. So we have to be able to read an NFA diagram and somehow figure out how to turn it back into a regular expression, if that's even possible. This is an easy one. There's my NFA. Can I write this as a regular expression? Now, why I said this is an easy one is because this is already laid out as basically a plus of three things. I have basically three parallel tracks here. And so by looking at the NFA, it immediately comes to my mind that this is really a plus of three things. So this looks like, that's why this is an easy one, because you can kind of look at it and tell. This looks like three parallel tracks. They're sort of across the top, across the middle, and across the bottom. And no loops at all, right? So actually the regular expression I'm going to use will use pluses but no stars, because in fact there are no arrows like going back. Every arrow goes from left to right. This is certainly not true of most NFAs, but that's why I said this is an easy one. It looks like three parallel tracks, no loops. I mean, there's no like looped edges, but there's not even any sort of big loops that you can run through in this diagram. So it'll be a plus of three things, basically. A plus of three things. I mean something plus something plus something, right? A sum of three things, I should say, if I was a sophisticated mathematician. So we should just do like the track across the bottom plus the track across the middle plus the track across the top. Maybe you've already noticed I didn't put a label on this arrow. It's supposed to be an A. Sorry, in my haste, I left out that. All right. So can we do it? The bottom track would just be BA, right? The middle is ABB. And the top, can anyone express the top? So the top is, I suppose, very slightly more complicated. How would I write the top? Because of those epsilons in there, it's slightly weird, I guess. Yeah?
It would be A star plus B plus A star.
I think I don't want to use stars. This can be A, or you can skip it, but a star would mean like you can do A, or something like that, which I don't want to do. Any other ideas? This is not a bad idea, but I don't want to use stars. Yeah?
Like in parentheses, A or epsilon.
Yeah.
B, then A or epsilon again.
I like that. A plus epsilon, B, A plus epsilon. All right. Excellent. Yeah. So that's how, I think that's the simplest way to write the top track. You could also, I mean, there are other ways you could have done this. You could also say the top track is something like, there aren't that many possibilities, right? You could do A, B, A, or you could skip this A and just do B, A, or you could skip that A and do A, B. So you could just plus all of those things if you want. A, B, A plus B, A plus A, B plus B. I think that's it. I think I said all the combination. There's not that many ways to get from here to here, and you can just write them all out with pluses. But anyway, so my final answer is, like, the total thing would be BA plus ABB plus this other thing, A plus epsilon, B, A plus epsilon. All right, that's my final answer for the regular expression. The moral of the story is, if there is no looping in the diagram, then it's just going to be a bunch of pluses, and it's basically never going to be hard to write down what all the various options are. All right? It's quite a bit more complicated when there are loops. So this is harder if the diagram has loops in it. And I don't necessarily just mean like single edge loops, but just any way of going back somewhere you already been in the diagram. Harder if the diagram has loops. We'll just try a few of those, and then I've got some for you to try maybe next time. How about this? All right. Harder if the diagram have loops. Let me just say, I mean, this is probably everybody would have come to this conclusion on your own. I'll say loops require the stars. All right, that's how you make a loop happen, is by using a star, although you have to use it in an appropriate and sort of smart way. All right. So when I look at this one here, I see basically two loops. There's this one, just this A, and then there's this larger loop. All right. So, and this is what makes these hard. You have to kind of look at the diagram and decide for yourself, first of all, where are all the loops that I would need to consider here. This, I would say, has two loops to consider. And one looks like A, and the other looks like ABA, right? And it starts at the accepting state, but starting here, you can do this A over and over again, or you could do this, ABA, over and over again. Or you could mix and match them, right? Like you could do the A a few times, and then the ABA a few times, and then back to the A a few times. All right? How do I combine all of this with stars and whatever? Well, I said or, right? It's this loop or this loop. So what it is A or ABA, the whole thing starred, right? That means I'm going to do a bunch of looping stuff, and each time through, that stuff that I'm doing in the loop is either just A or ABA each time. This is how I would write this as a regular expression. It's much less clear, and it's, I mean, to do it this way, rather than going regular expression to NFA is just a matter of patching together the appropriate pieces. Here you have to look at the thing and somehow decide on your own what the appropriate things are, which is more difficult. All right, I got one more, and then maybe next time we'll start off with you guys trying some. This one was made easier because I started in the accepting state, but of course that's not always going to happen. Here's a harder one. All right. So the way that I think of this one is, I still see two loops basically. There's the A, the single edge loop A, and then there's this AB loop that I could do here. But you have to get to the you have to get to the accepting state to begin with, all right? So I'm going to say the way, like when I look at this diagram, the way that I think of this is you have to first do B, then we have two choices of loops, right? And those two choices of loops I'm going to write with a plus and a star. just like the previous example. But we have to do a B first. Anybody see where I'm going with this? Anyone want to try and tell me what it's going to be? What should I write first? B. Yes, thank you for reading my words. First, do B. Yeah, you begin with B, all right? And this B that I just wrote is never going to be part of a star because that's not part of any of the loopy stuff that has to happen. So just B first, followed by, next I do whatever about the loops. Somebody else want to shout it out? Yeah? What do you say?
So regular expression?
Yes?
A or AB star?
I like that. Yeah, A or B, A or AB, and that whole thing inside a star. I think that's what you meant. Yep. Yeah, this will do it. So you got to do B first to get here, and then you got to do either this loop or this loop as many times as you like. I agree. These have both been somewhat easy examples. We'll try some more fancy ones next time. Maybe that'll do it. I had some for you to try, but I don't do that right at the end. All right.